Okay, we're looking at part 2. When we're looking at quadratics, the discriminant, which this is the quadratic formula, the discriminant that b squared minus 4ac tells us some important information. If we calculate it and we get a perfect square, it tells us that this is factorable over the rational numbers, over q. If we get a positive number but it's not a perfect square, it means it's factorable over the real numbers, and that includes irrationals. So that's when we have factors like x minus the square root of 2. And if we get a negative, we cannot have a negative square root, so that's why we say no, it is non-factorable. So when you get a quadratic, you can always check using the discriminant to find out if it's factorable. Okay, we will do some examples. Our first one, 45x squared plus 14x minus 187. So, I don't know what I just did there. Cool. Okay. So first I'm going to identify my A, B, and C values. So A is the first term, second term, and third term. Now I'm going to calculate my discriminant. So B squared minus 4AC. Putting in the values, I'm going to get you to pause the video, see what you come up with as a value. Okay, I got 33,856. This is in fact a perfect square. It is 184 squared. So because we got a perfect square, we know that this is factorable over the rationals. I will let you try the next one on your own. Hopefully you paused, you calculated out. I got 765. That is not a perfect square, so I know that this is factorable over the real numbers. It will have irrational factors. Next up, we're talking about cubes. And there is a formula. It's found on page 11, and you're looking for number 8. It's in a square, and whenever we have a sum or a difference of cubes, we follow this pattern. So this is the same pattern we're going to use. One way to remember it is the acronym SOAP. So same sign. If we have A plus B, same sign, positive. A minus B cubed, same sign. Then we have the opposite sign. So here we have a plus, it becomes a negative. Here we have a negative, it becomes positive. And then we have always positive. That last term is always positive. Okay, so we're going to follow this pattern as we go to factor. We're going to factor a cubed plus 6. So first of all, I notice this is a sum of cubes. So I'm going to be zeroing in right here for this first one. Zeroing in on that. So first of all, I'm going to rewrite it as perfect cubes. Well, that is a cubed, that's a perfect cubed, and the cube root of 6, all cubed, is the same as 6. So now I have kind of those A and B values that then I can plug into this formula. So, following the process. First of all, we take the cube root of the first term, A. We take the cube root of the second term, the cube root of 6. Remember, S in SOAP means same, so we have a positive. Then we take the first term, that A, and we square it. So we have A squared. Then we have the opposite sign, negative. A times B, or A times cube root of 6. Then the last term is always positive. This can be simplified because the cube root of 6 all squared is simply the cube root of 36. So pause if you need to get this written down, but this is just a matter of kind of following a pattern, following a formula. Continuing on to the page, if you look at point number 9 in your textbook, it talks about the differences of powers, in fact, always follow a pattern. And so if something has 4 terms, then we would go A minus B if it's a difference. And then look what happens to these powers here. Let's see if I can get my pen to work. There we Sorry for those technical troubles. A minus B, and let's see what happens. We go A cubed, not going to work, computer. A cubed, notice what happens. The A goes down in value. That's like A1, and that's A to the 0. So the powers of A go down. The powers of B, this is like 1, 2, 3, they go up. And in fact, this can be extended on. We could have A to the 5th minus B to the 5th, and we're going to follow that same sort of pattern. So take a second pause here and see that you notice that pattern. The second term always has the same number of terms, that second factor, as the initial power. So A to the 5th, the second term has 1, 2, 3, 4, 5 terms in it. So a check there. And in fact, we could do this with any number. So if we have x 7th minus x1, following the pattern, we would go x minus 1. The powers of x go down from 6 to 0, and the powers of 1 go up. I didn't write 1 squared, 1 cubed, 1 to the 6th, because those are all just 1 to the power of anything. So this was a simpler example.